Just off the coast of Fujian province, a white tower rises slowly through thick sea fog that conventional engineering said should never exist at this scale. Its rotor alone, blade tip to blade tip, spans 252 meters, wider than any aircraft wingspan ever built. One single rotation generates enough electricity to power a household for an entire month. China did not stop at one machine. It built an entire fleet, scattered across one of the most contested waters on Earth. This is not a story about a turbine. This is the opening move in a global energy war. Get close to the water and the scale stops making sense. The rotor is 252 meters across, roughly the height of a 63-story building lying on its side. Each blade is about 126 meters long, longer than 4 football fields end to end. Together, the 3 blades sweep an area of about 50,000 square meters, roughly 7 football pitches turning in a single circle, out in the corridor of sea that separates mainland China from Taiwan. A support vessel idles beside the tower, and next to it, the ship looks like a toy. The blades are not steel, and they are not standard fiberglass. They are built around a carbon fiber main spar, because at this size, ordinary material would simply be too heavy to turn. This looks like a wind turbine, but once you understand why it exists, it stops being a wind turbine and starts looking like a machine built to solve a problem most viewers have never heard of. That problem starts on a map. China's coastal provinces, Fujian, Guangdong, Zhejiang, Jiangsu, are the manufacturing engine of the country, and they devour electricity. But most of China's coal sits deep in the interior, thousands of kilometers from the ports and factories that need it, and every kilowatt that travels that distance bleeds energy along the way. The fix is to generate power where it's consumed. The coast has one resource the interior doesn't: wind, blowing hard and constant across the Taiwan Strait, almost on top of the cities that need it. China's 2030 target is 1,200 gigawatts of combined wind and solar, and offshore wind is the fastest growing piece of it. The math is brutal and simple. One turbine like this saves roughly 35% of seabed area compared to a farm built from older 8-megawatt machines. Fewer turbines, fewer foundations, fewer underwater cables, lower cost per megawatt. That sounds straightforward until you look at where China decided to put it. The Taiwan Strait isn't just a wind corridor. It's one of the most violent stretches of water on the planet. Level 7 near gale winds over 32 miles an hour hit this corridor more than 200 days a year, and typhoons roll through with some of the strongest winds the Western Pacific produces. Turbines in this class are engineered to survive gusts approaching 179 miles an hour. Standard offshore turbines before this generation topped out around 12 to 14 megawatts. Past that, designers hit a structural wall. As blades get longer, the forces twisting and bending them grow faster than ordinary materials can handle, and a nacelle weighing hundreds of tons still has to be hoisted more than 120 meters above a sea that can turn violent within hours. The engineering was the first problem. Installing it was a completely different category of impossible. China's offshore wind industry already didn't start at 16 megawatts. It started near zero in 2010 and climbed in steps 3, 5, 8, 12 megawatts, and every smaller turbine meant more foundations, more cable runs, more vessel trips, more maintenance crews per unit of power. The obvious solution was to go bigger. The problem was that nobody on Earth had built a machine capable of lifting something this big, this high above the water, in seas this rough. And here's the twist most coverage skips. The real constraint was never the turbine. It was the absence of any ship that could install it. Setting a 252-meter rotor in place means lifting more than 400 tons above 120 meters in shifting sea states while aligning blade bolts to millimeter precision. No vessel built for that existed when this turbine was designed. China had to build an entirely new class of jack-up installation ship with legs that grip the seabed and crane arms strong enough for turbines of 15 megawatts or more, each costing hundreds of millions of dollars and years to build. That fleet of ships is not a footnote. It's the actual precondition for exporting this technology anywhere else on Earth. Without the ship, the turbine never leaves the factory. Once you understand the vessel problem, the location starts to carry more weight than it first appears. This turbine rolled off the line at the Fujian Three Gorges Offshore Wind Power International Industrial Park, a government industry site built directly across the strait from Taiwan. The wind here is genuinely exceptional. That's the real reason China chose this corridor, but it's also one of the most geopolitically watched stretches of water on the planet, and every turbine planted in it sits where energy infrastructure and territorial tension already overlap. The real reason China cares only becomes clear once you zoom out past the weather. This is also where the title's biggest claim has to be tested honestly. There is a real engineering principle called the square-cube law. As blades get longer, the power they capture grows with the square of their length, but the structural weight needed to hold them up grows with the cube. In theory, that creates a ceiling. Past a certain size, turbines should collapse under their own mass before they generate enough power to justify it. China didn't break that law. It out-engineered it. The carbon fiber main spar cuts blade weight by more than 20%. The nacelle uses an integrated E-top design that shrinks the number of separate lifts needed at sea. Buried inside is the most overlooked breakthrough of all, the main shaft bearings. They were never before manufactured inside China at this scale. They were previously imported from European suppliers, a quiet dependency at the center of every turbine. Building this machine forced China to develop its own bearing manufacturing. Even the blades created a logistics problem nobody talks about. At 126 meters, they cannot travel on a normal road and need custom transport rigs or direct sea transport just to reach the coast intact. None of this happened in a vacuum. The company financing and deploying these turbines is Three Gorges Group, the same state-backed organization that built the Three Gorges Dam, the largest hydroelectric structure on Earth. The logic is identical. Enormous state capital, a multi-decade time horizon, and a willingness to absorb risk private investors would not touch. China used that playbook to dominate inland hydropower. It is now running the same playbook offshore, and Three Gorges Group is already the country's largest offshore wind developer. This is where the project stops being about wind and starts becoming something much larger. China already controls most of the world's wind turbine blade manufacturing capacity. Goldwan, the company that built this machine, is China's largest turbine manufacturer and one of the largest in the world, competing directly with Vestas, Siemens Gamesa, and GE Vernova. Every component this turbine proved it could build domestically, from blades and bearings to an integrated nacelle, is a component other countries will eventually buy from China instead of Europe or the United States. A turbine sale isn't just a turbine sale. It comes bundled with Chinese technical standards, maintenance contracts, and spare parts for the machine's entire lifespan. This is where a turbine stops being a turbine and starts becoming a trade standard. And the record never stood still. By the time this 16-megawatt machine was being installed and commissioned, according to project announcements, China had already moved on. 20-megawatt turbines arrived around 2025. Dongfang Electric completed a 26-megawatt offshore unit the same year per CGTN. China is now installing roughly 75% of all new offshore wind capacity added globally, according to Bloomberg Television. The pattern mirrors solar, where Chinese manufacturing scale drove panel costs down more than 90% in 15 years. If offshore wind follows that curve, it becomes cost competitive with fossil fuels well before 2035. And whoever controls the factories controls the transition. But the cost curve is only half the story. None of this solves the problems that do not make it into a press release. Routine blade inspection at 120 meters above a typhoon-prone sea still requires specialized vessels and crews willing to work in genuinely dangerous conditions. The power still has to travel to shore through submarine high-voltage cable, expensive to lay and complicated to repair when it fails. Offshore wind in China still costs more per megawatt than onshore. Scale is supposed to close that gap, and it is closing, but has not yet. And any country that imports this technology inherits more than clean electricity. It inherits Chinese software platforms, spare parts pipelines, and a maintenance relationship that can last decades. That is the same dependency structure built into Chinese rail, port, and road exports. Real benefit and real constraint in the same package. If this technology keeps scaling, the consequences are real on both sides. Each unit like this one is reported to cut about 54,000 tons of carbon dioxide a year. Multiply that by thousands of units, and the impact stops being symbolic. Coastal nations across Southeast Asia, South Asia, and parts of Africa, places currently dependent on imported coal or gas, could gain locally generated renewable power within a few years of signing a contract. But they would buy it financed through Chinese capital, built with Chinese equipment, serviced through Chinese networks. What it cannot solve is China's own coal transition, still running in parallel on a grid that still leans on coal for the power these turbines do not yet replace. This 16-megawatt machine was a world record in November 2022. It was never the destination. It was proof that a square cube law everyone assumed was fixed could be engineered around. Proof China could build the ships, the bearings, and the blades a project like this requires from scratch, and proof of concept for the 20-megawatt, 26-megawatt, and floating deep water turbines that followed within 3 years. The same organization that poured concrete into the Yangtze to build the world's biggest dam is now driving steel and carbon fiber into the open ocean, using the identical formula of state capital and overwhelming scale. The medium changed. The strategy did not. If this helped you see what China is actually proving offshore, not just a bigger turbine, but a vessel fleet, a bearing supply chain, and an export-ready energy standard, subscribe. Because the floating deep-water version of this technology is already changing the map in ways this video has not covered. But here is the question worth sitting with. When one country drives the cost of clean energy down for the whole planet by controlling every link in the supply chain behind it, is that the smartest industrial strategy of the century, or leverage wearing the costume of generosity? The next 10 years will answer that, whether we are ready or not.